Hello everyone and welcome to the Math Bender. I'm Adnan Zaidi and in this session we'll discuss sine rule as an extension of area of triangle. Let's start. So we have a figure, let's say a triangle with sides with angles A, B, C. The side that is opposite to A, I'm just naming it as small a. The side opposite to angle B is small b, and the side opposite to angle C is small c. We already have established that the area can be written as 1 over 2 times if I take the product of A and B sine of angle C. It is as same as 1 over 2 times A and C if I'm taking these two sides. The angle that is in the middle is sine of angle B. It is as same as 1 over 2 BC sine of angle A. So let's take any of these two and try to compare. So 1 over 2 AB sine of angle C is equals to 1 over 2 AC sine of angle B. I can cancel this half with the other, A with the other, and as I can see that I am left with B sine angle C is equals to C sine angle B, or sine of angle C over C is as same as sine of angle B over B. This is sine rule. In short, if you want to understand rather than remembering the formula, it's always better whichever angle that you're taking, the opposite side is going to be as denominator. So let's see some of the questions. If we have a basic triangle, the first step is to identify whether it's a right angle triangle or not. And as you could see that it is not. So I'll straight away apply sine of angle 62. The side that is opposite is 66.25. And this is equals to sine of angle 38.7 over FE. You can replace X as well if you want to. FE is going to be 6.25 sine 38.7 over sine 62. I just cross multiplied both sides. Now, so 6.25 sine 38.7 over sine 62. This is going to be 4.4. Now, to completely find all the angles and all the sides, let's find the first this angle. So as I can find, angle F is equals to 180 minus 38.7 minus 62. So this gives you angle F as 79.3. So let's write that down. Now you have to find the side that is opposite to that angle. So straight away, using another sine of 62 over the opposite side 6.25 is as same as sine of 79.3 over dE. And dE is 6.25 sine of 79.3 over sine of 62. So dE is going to be 7. Let's see a little bit more complex example. I'll only solve this one, this part. We already have established and discussed area in the other videos. So in order to find the distance AC, this is the distance. And it is covered by the triangle ABC. And if I have to find out the side, I need to apply sine rule because it's not a right angle triangle. And if I have to take this angle opposite to this side because that's the only side that I have, I'll have to find this angle as well. So angle A is going to be 180 minus 68 minus 62. So this is going to be 50. Now sine of angle 50 over 6 is equals to sine of angle 62 over AC. And AC is going to be 6 sine 62 over sine 50. You can plug it in your calculator and check the values. Now let's look at this question. So it's a metal framework in which AD is horizontal, straight line, and you're to find out the length of the metal bar AB. So this is what you're to find. And as you could see that this length AB and this height, straight away it's a mixed question of right angle triangle. So as I could see, it's a right angle triangle, and I straight away, well, what I'll do is I need, according to the angle 25, the opposite 5.3 is given, and this is the hypotenuse. So I'll straight away, rather than going into sine rule, opposite, which is 5.3 over h. So AB or h is equals to 12.5. The angle BD makes with BN. So if you see this, this is BD and this is BN. So angle in between is this. So I need, according to this angle, and it's a right angle triangle, still we have trig ratios in play. So according to this angle, BN is 5.3, which is the adjacent, and BD is the hypotenuse. So I'll use cos of angle B is 5.3 over 7.1, and B is equals to B is going to be 41.7 degrees. the length of the metal bar CD. So this is the length they're talking about. Now, so as you could see, the triangle BCD is not a right angle triangle. So all the trig ratios and the Pythagoras theorem, all the tool bag that we were using before for right angle triangles are going to be replaced by sine rule. So the first thing that you so far know is sine rule. So how do you apply sine rule? As you could see that the angle 103, the opposite side to it, this is what you're to find, and the angle opposite to the side angle opposite to 7.1 is C. So if we can find out that angle, because we already have two angles, so let me roughly draw this figure here. This is C, this angle, this is 7.1, this is 4.46 degrees, and this is 103. So I need to just find out this length. I can find this angle, 103 plus 46 is going to 149, and 180 minus the answer is 31. So this angle is 31. So sine of angle 31 over 7.1 is going to be sine of 103 over x. And x is equals to 7.1 sine of 103 over sine of 31. So the angle is 13.4. Sorry, the length is 13.4. Let's look at another question here. You have to find out the length of QR. So for QR, it is a part of a right angle triangle, and straight away, rather than getting into any other rules, you know that the trig ratios are in play. So according to this angle, this is the opposite, and hypotenuse is given to you. So straight away you apply sine of 27.6 is QR over 5.7, and 5.7 sine 27.6 is QR. .64. So QR is 2.64. To find out the angle SPR is this angle. Trace it. So this is SPR, and it is also a right angle triangle. As you could see, there's a square sign there. So according to this angle, this is the adjacent and this is the hypotenuse. So cos of angle P is adjacent, which is 3.2 over 5.7, and P is equals to cos inverse 3.2 over 5.7. So P is going to be 55.8 degrees. Now PST, the angle PST is this angle. So for that angle, since it's not a right angle triangle, and the only tool so far you are aware of is sine rule. So let's try applying it. So sine of angle S over 2.7 is going to be sine of 64.2 over 3.2. Sine of angle S is going to be 2.7 sine of 64.2 over 3.2. So sine of angle S is 0.76, and if you want to find out S, it's going to be sine inverse of 0.76. S is going to be 49.4. So you could see that sine rule can not only find you the length but also the angles depending on the condition that you're applying onto. This is it for today's session. In our next session, I'll discuss cosine rule and some mixed questions along with sine rule. Until then, take care. Bye.